So, welcome to the amendment of the first video. So I'm going to fix Charles's law. Charles's law is a relationship between volume and temperature, and here we're keeping pressure and number of moles constant. Well, how is temperature and volume going to relate? Let's think about it. If we increase temperature, that means that the kinetic energy is increasing. The kinetic energy is increasing, they're moving faster. If they're going to move faster, that means they're going to cover the area between the walls quicker, which means that there's going to be more collisions in a given amount of time, which would cause pressure to increase. But since pressure has got to stay the same, if the natural inclination is for pressure to increase, then we need to figure out with Boyle's law's relationship, how will we change volume since pressure needs to be constant? Well, if pressure is going to increase, then we need to reduce pressure. And the way to reduce pressure from Boyle's law is to increase volume, because we're trying to decrease pressure, which means volume needs to go up. That's exactly what's going to happen here. We're going to increase temperature, volume will increase. Well, then how are they going to relate in terms of their constant? Well, it's either going to be volume times temperature or volume divided by temperature to equal some sort of constant, right? So if we have B equal to 1 and we have V and T to 1, then that's not going to matter which one we do. But if we make our change, so if we make temperature 2 and we've already decided that volume is going to go up if temperature goes up, if one doubles, the other doubles. Well, which one of these is going to maintain a B value of 1? If I put it in here, 2 times 2 is going to equal 4. 2 divided by 2 equals 1. It's going to be division that ends up being our equation, the relationship between volume and temperature. And of course, Charles's law, the functional equation that we're going to use is V1 over T1 equals V2 divided by T2. Done.